Hello everyone, welcome to Practical GCP. So today I want to focus on my experience on how effective is history-based optimization on BigQuery. If you don't know what it is, it's called history-based optimization, and it's a new feature that's been released into GA on BigQuery. And the way it works, it seems to be that all the queries you ran historically, right, those queries will be used to contribute to the insight for optimizing queries you're going to run in the future. So this means it's not just about the same query. Let's say you repeat the same query again tomorrow with some new data in your table. It's not just that. It's also when you are running similar queries, right? So the query doesn't have to be the same, and you still get the performance benefit. If you look at what it's saying here, so according to Google, the history-based optimization can actually give you cut up to like a 67% of the slot time savings, right? So this means your query will run a lot faster and it will save you cost, specifically because everyone today should be using auto scaling, right, with the new BigQuery additions. So this means it's more significant because you're now using less slots, and then you have your utilization, which is a lot better. So what I'm trying to do or prove is to test this feature, especially on some of the common queries that we run every day on scheduled jobs. And I always want to see, what the outcome looks like and what's the actual percentage savings based on those query patterns that I run. So the first thing is if you because it's being rolled out still into different regions. So if you do want to use it, you need to enable it manually using this thing, right? Using the Otter project SQL query. So you just have to turn the adaptive to on that project, but don't worry about it. You can turn it off as well. So it's not a problem. So, but first of all, let's talk about the effect on full refresh or full load models. So this is basically in many scenarios, data engineer would rely on this sort of truncate and insert pattern for data sets that are not particularly large and you don't really update it very frequently. So this is like daily jobs, right? Without a lot of data you're processing. The reason for that is this approach really simplifies things a lot, and you don't have to deal with the delta tracking use cases. And when you have a lot of these, it can get quite complicated. The issue with that is as your data size grows over time, so the cost can actually increase, and this can be quite significant. So for those workloads that run daily, what you typically see is just a new date, like partition gets added with additional data, right? If you just run the whole table every day, then you basically get that new additional partition on a daily basis. So what I want to see is the performance impact by enabling history-based optimization on this sort of workload. So to test this, if you can see here, I'm actually using this table is kind of has got quite a lot of data, typically like 400 megabytes per day. It's called the International Top Rising Terms, right? It's from the Google public dataset. So what I've done with this is I've used everything from the 15th of October, which I know there's some data in there starting from that point, but every day I will just add more data to it. So keep in mind, I'm not using equals, it's just a less than. So what that means is I'm always adding more data into the query to simulate, let's say in the case that every day you run your full load, and then you have more data into your table, right? So that's what I'm trying to do. So what I'm expecting is that while the optimization may not be applied immediately, what I'm hoping for is if I run it a few times, because Google claims that if you run similar queries, it should understand to how to optimize the ones in the future, right? So if I run a few, I should be able to see a pattern, and it start recognizing the cost saving benefit and start applying the optimization. So now, if you look at this, this is actually giving some very interesting results. I've got the 15th, right? If you look at all the way from the 15th to the 21st, there is no optimization in here at all. And this is quite interesting because the reason, right, I think, is because if you look at the amount of data that we have in the partitions, you can see from the, I included a few more days, right, from the 13th all the way to the 20th, there's not much data at all. But from the 21st onwards, there's a lot more data, and all the way to the 30th or 31st kind of in our test, right? So, and you can see the optimization, it can't be bothered, right? Because it makes perfect sense. It doesn't do any optimization when you have too little data. But it also didn't apply optimization on the 21st partition, right? So when I'm running on the 21st, because that is the first time, there is actually a lot more data. So I don't think it actually think it can do that. But you can see from the 22nd, although there's one gap, but almost 100%, close to 100% consistency, it will always do the optimization after that point, right? So you can see this is, you have a daily similar size, but they're not exactly the same. They're just similar. So this is actually very, very interesting. So now we know the optimization has been applied, but what is actually the impact, right? Did it actually save cost? And if it did, how much, right? So let's look at this query that Google Cloud provided in this example. It does it by trying to link the, what is it called, the normalized literals, which is basically the query hash. The way, if you look at this, the way this works is that if you have, in this case, the 29th and the 30th, right? The rest of the query is identical, but the date that's being included in here is not the same, right? So one is the 29th, one is the 30th, but these two have the same query hash. So they're trying to use this to compare. And this is what we see. So what that means is every day I'm adding another day worth 400 megabytes, right? So the compute will be higher. So if you always compare that with the same one, let's say it didn't do the optimization at the very beginning, then you can see this is why the elapsed the time that in here has not been changed for all of this stuff, right? So it was comparing with the last one has not been optimized, but that's not fair, right? Because the last one has not been optimized. Could be a really old one that with a lot less data, with a lot less partitions. So that's never going to work. So this is why you see in the percentage execution time saved is negative, right? But this is not actually true, right? So I'll prove it to you in a second, and why I'll explain why this is not true. So instead, what I've done is I've turned off the history-based optimization, and I rerun all the queries, all the 16 of them. So just basically because it was turned on, right? Now it's turned off. I just rerun everything. But now, every time, basically what I'm doing is, you can see the query in the link in there. But what I'm doing is I'm extracting the date, right? So the less than date, and use that as the joint key. So I can now see what is this before and what is after exactly on that until date to see the impact. And so now this is what I'm getting, which is a lot more promising. You can see this slot kind of a consumption time and the how long the query took to run. It's in comparison, you always have a positive number. Some of these are not significant, but some of the others, you can even see there's almost 26%, right? On the saving of the what the optimization has done. So this is very, very interesting. So what this means is, if you're on demand, if you're using on-demand billing, then your query or some of your query could finish up to 25% faster. I think that's a pretty big deal, especially in the morning. Sometimes your query is late because it's a bit more data. 25% can be very significant. If you're using slots, especially when you have auto scaling, so which everyone does right now with the new kind of additions, then in average you're saving like 12%, right? That is still pretty significant. And keep in mind, the thing is, I've only tested relatively simple queries. So this is just full load with one table. But if you introduce more complex queries such as joins, window functions, or subqueries, this could give you potentially much greater performance gains. So yeah, it could be interesting. So next, although not everyone run full load on your workload, So especially when you have much larger data set, or you need your data to run or updated a lot more frequently, you're likely going to use an incremental approach to update your models, um, relying on some sort of forms of delta tracking, right? So in this case, for example, we're still using the same table, the international top rising terms dataset. Um, so what we're doing here is, if you look at this one, we're changing the less than into equals, and we still run the 16 queries. So what's happening here is every day we're only running 1 day worth of data. So, with these really small partitions, you're talking about like a 20 megabytes. But starting from the 21st, we would have 400 megabytes per day, right? So that's the query run. Let's see if it actually saves us anything. So because we already know that the optimization won't be applied when the processing is very small, so you don't have much data, so in the small partitions. So my expectation is that for the first query, so for example, processing data for just 1 day, like the 21st, that query won't be optimized. But as I start running the query from the 22nd and beyond, I'm hoping that every single subsequent query will benefit from the optimization. And this is what I'm getting, right? This is actually amazing. If you look at this, it's very clean. From the 15th to the 21st, no optimization. And 21st, keep in mind, that's the first day we have the big partition. And going forward from the 22nd, you've got your first optimization kicked in. And every single other day, you always have optimization applied. This is amazing. Exactly what I expected, right? So if you want to know which query I ran to do this, here's a link. You can use this. So basically, no optimizations were applied for the smaller data partitions. However, starting from the 22nd, and it leverages the history from the 21st, right? And then all the subsequent queries are successfully optimized. So, which is amazing. If you look at the impact, so the same query I run, but I've changed it to match it based on the equals instead of the less than. Now you see, so also keep in mind now I'm processing a lot less data, right? But percentage-wise, it's quite interesting. You still have some of these are 16 or close to 17% saving or better, right? There's one that a little bit worth, but you can see this is very, very, it's just occasionally you get one of these, but that's also the 0.29%, right? That's not 2%. So that's the so this is what I'm getting. So as a result, if you're using on demand, up to 17% faster query execution times on slots, about 10% cost saving on these simple queries. So those the incremental daily partition based on a date, 400 megabytes, right? What I'm trying to say here, and what based on what I've tested, is it's great to see that history-based optimization in BigQuery can reduce compute costs even for similar queries. This is a big deal, right? This is a significant benefit for all BigQuery users. So imagine getting 25% improvements in query runtime, or 10 to 12% cost saving by doing nothing, right? It's quite a big deal. These results are based on obviously my limited testing with simple queries. But if you start using more complex queries and processing larger data set takes much longer to run, I think this could be a lot more substantial. So that that Google basically saying 67%, you actually might be able to get that in some of these very large queries. But I've not tried this yet. So what I really like about this is, and what is really impressive is to me, is how Google is rolling out such an impactful cost-saving features, and they just immediately pass it to the customers, right? So they're not keeping this to themselves. So personally, this is a big deal, all right, and it's probably one of these things why I really like, to use Google Cloud, and they do a lot of these things. I can give many other examples. It's basically you have very brilliant mind, right? Engineers within Google, super smart people. They're solving very tough problems, such as this history-based cost optimization. This is a really hard problem. If you think about it, you don't have to do anything as a customer, but it just works, right? And then it would deliver these very impactful improvements to you or to me, then it requires literally zero effort for you to adopt. This is such a big deal. So I'm really excited that you don't try it out to see. I want to see what you've got from this thing, what you can achieve from your queries. If you just enable it and then see what it looks like in your cost dashboard, in your slot utilization, these things you can easily check, right? If you don't like, you can turn it off. But from all the things I've checked, there's everything is better, right? Is the slots usage is a lot less for these similar patterns and queries. So I think this is very, very useful for specifically the scheduled jobs, right? In this case. Yeah, so I think that's it, and I hope this is useful. I did also write a blog post on this as well. So if you need the examples, the code, and you can actually, it's much easier to go there and then copy and paste and run it yourself in there rather than use the video and trying to do this. So yeah, thank you very much, and this is amazing. I will see you next time.